Okay, so get this. For like over 50 years, 56 years actually,
Huh?
everyone just knew that multiplying these two 4 by 4 grids of numbers, it took 49 steps, 49 multiplications.
Right, that was the standard, the best anyone had found since, what, 1969?
Exactly. Seemed totally locked down. Then, boom, DeepMind rolls out this new AI, AlphaEvolve.
And it finds a way to do it in 48.
Just 48, one less. It sounds small, maybe, but honestly, in computing, that's huge.
Oh, it's a big deal, definitely.
So stick around. We're going to unpack exactly how that happened and, what it really means for what AI can actually do. Welcome to the deep dive. We cut through the noise to get you the breakthroughs that count.
And today, yeah, we're diving into AlphaEvolve. Google DeepMind just announced it, like days ago, May 14th.
Right, and our mission today is pretty clear that figure out how this system, and people are calling it spectacular, solves these really tough science and engineering puzzles.
By writing its own code, essentially, and then making it better.
Exactly. Writing and improving its own code. We'll look at the wins it's already had, what it means for AI discovering new stuff.
And we'll keep it straightforward. No jargon overload.
Definitely. Keep it clear. Keep it interesting.
Okay, so the core concept. They call it an evolutionary coding agent.
Right. Which sounds a bit technical, maybe?
Maybe. Think of it like this. Imagine a really sharp scientist always brainstorming new ideas.
Okay.
But this scientist also has like an incredibly thorough assistant built right in, one that tests every single idea immediately.
Ah, I see. So brainstorm test.
Exactly. Bad ideas, gone. Good ideas. They get tweaked, improved, made better.
Yeah.
That's basically what AlphaEvolve is doing.
It's like a genius brainstormer who's also, I don't know, its own harshest critic, constantly checking its own work.
That's a great way to put it.
Yeah.
It is its own critic.
So how does that cycle work? The brainstorming and the self-checking?
Well, it starts with a problem, obviously. Could be anything from making a data center run smoother.
Or like that matrix thing you mentioned.
Or finding a faster math calculation, yeah. And crucially, you give it clear goals. Like, this is what success looks like for this problem.
Okay, define the win condition.
Right. Then the really cool part starts.
And this involves some heavy-duty AI, I assume, the large language models, the LLMs.
Oh, absolutely. It uses DeepMind's Gemini models. These huge AI models trained on just tons of text and code.
So they can generate solutions.
Exactly. They can generate potential solutions. AlphaEvolve actually uses two different Gemini models. There's Gemini Flash, which is faster.
Okay.
It throws out a whole bunch of initial ideas, casts a wide net, you could say.
Get lots of possibilities out there.
Then, the more powerful one, Gemini Pro, takes the best of those initial ideas,
Yeah.
the most promising ones, and refines them, adds more detail, more precision.
Ah, okay. So breadth first, then depth. Makes sense.
That combination is really key to how it works.
Okay, so Gemini brainstorms all these potential solutions, these little bits of code or algorithms. Then what? It doesn't just, take its own word for it, right?
No, definitely not. And that's where the self-check and the self-evaluation comes in. This is really what makes AlphaEvolve stand out.
The critic part.
The critic part, yeah. Each idea, each potential solution gets run through this automated testing program rigorously.
How does that work?
The program checks exactly how well the solution meets those goals we talked about, the success criteria. So if the aim is saving energy, the evaluator measures the efficiency of the code in, like a simulation or maybe even a real test environment.
So it grades its own homework. Hard.
Very hard. Extreme rigor, yeah.
And only the best ones, the A+ students, get to move on.
Pretty much. The system looks at the high-scoring solutions and uses them as the starting point for the next round.
Ah, inspiration for the next generation.
Exactly. The LLM sees what worked, generates new variations based on that success, and the whole cycle repeats. It evolves better and better solutions over time.
And the weaker ideas just fall away.
They're discarded. Keeps the whole process focused and efficient. It's this constant loop. Generate, test, learn, improve.
Wow. It really is like a super fast automated science experiment loop.
Kind of, yeah.
And the final output, it's not just some AI code only another AI can read, is it?
No, and that's super important. It spits out high-quality code that, actual human engineers and scientists can read and understand.
Okay, that's crucial.
It really is. Because it means people can look at the algorithm, figure out why it's better, check for bugs, and actually put it into real systems. It's not some black box mystery.
Transparent, actionable.
Exactly.
Okay, so we've got the process. AI brainstorms, AI tests itself ruthlessly, AI refines based on what works and gives us usable code. Sounds amazing in theory. What about results? What's it actually done?
Yeah, the results are pretty impressive, especially the range. DeepMind's been using this internally for, like, over a year now.
Oh, really? Okay.
So take data centers. Huge energy sinks, complex scheduling problems. AlphaEvolve found a new way to schedule all the jobs running in Google's data centers.
And the impact?
It recovered about 0.7% of Google's entire worldwide computing resources.
0.7%. That sounds
Yeah.
small, but maybe not at Google scale.
Exactly. At Google scale, 0.7% is massive. It's like finding a huge chunk of hidden computing power they didn't know they had. And it saves a ton of energy, too.
Wow. Okay, that's a real-world impact right there. Quietly running for a year. What else?
Well, moving down to the hardware level, Google's TPUs, their custom AI chips. AlphaEvolve helped optimize part of the design. It looked at the hardware description code for a math module inside the chip and basically found ways to simplify it, remove unnecessary bits.
It redesigned a chip component?
Sort of, yeah. Optimize the code that defines it. And importantly, this change passed all the super strict hardware checks.
So it actually works and is safe?
Yep. And they're putting this into the next generation of TPUs.
Yeah.
So potentially faster, more efficient AI chips coming down the line.
So it's tweaking software, it's refining hardware design. You mentioned AI training earlier, too, making AI itself faster.
That's right. Training these huge AI models involves tons of matrix multiplications, very intensive calculations. The core math of AI, basically.
Pretty much. AlphaEvolve found a better way to do one of the key large matrix multiplications. That specific calculation got 23% faster.
23%.
Yeah, which translated to about a 1% reduction in the total training time for Gemini itself.
Again, 1% sounds small, but for training Gemini, that must save enormous amounts of time and compute power.
Absolutely enormous. Time, power, money. It all adds up when you're training models that big.
Incredible efficiency gains.
Yep.
And it didn't just go after the big stuff, right? It also looked at software that was already supposed to be super fast.
Right. It tackled something called flash attention.
Oh, yeah, I've heard of that. It's a technique to speed up how transformer models, like, process information.
Exactly. It's already a clever optimization. But AlphaEvolve managed to boost its speed by up to 32.5%.
32% on top of an already optimized process.
Uh-huh. That kind of improvement on highly tuned code is really rare. Usually that takes, like, specialist compiler engineers months or years.
So this will save energy every time those AI models run, basically. Huge ripple effects for efficiency.
Okay, making big things faster, making fat things way faster. Let's go back to that matrix multiplication thing you started with. The 4x4, 49 down to 48. That sounds like pure math.
It really is a standout result. Multiplying two 4x4 matrices of complex numbers, the best-known way needed 49 multiplications. Held the record for 56 years.
Since 69.
Since 1969. And AlphaEvolve just found a way with 48.
And the crazy part is, this wasn't an AI designed just for math problems.
That's what's so wild. This is a general-purpose system. And even crazier, DeepMind actually had a specialized AI called AlphaTensor, built specifically to find better matrix algorithms.
Okay.
AlphaEvolve beat AlphaTensor on this specific 4x4 problem.
Wait, the generalist beat the specialist in the specialist's own game?
Yep. Like the decathlete beating the high jump champion in the high jump. It's pretty remarkable.
Well, that is just
Yeah.
mind-boggling. So it's not just optimizing computer stuff, it's actually tackling unsolved pure math puzzles, too.
Exactly. They tested it on over 50 open problems in different areas of math. In about 3/4 of them, it managed to find the best solutions humans already knew, just rediscover them on its own.
Okay, that's impressive validation.
But even cooler, in about 20% of the cases, it actually improved on the best human results.
It found something new.
Yeah. Like, there's this thing called the kissing number problem. How many spheres can touch one central sphere without overlapping? In 11 dimensions, which is hard to even picture.
Right.
AlphaEvolve found a way to pack 593 spheres. That beat the previous best-known lower bound.
And that's a problem mathematicians have worked on for ages.
Centuries in different forms and dimensions, yeah.
So, wow, this isn't just an optimization engine, it feels like. Potential for real discovery, actual new science or math. What are the experts saying?
The reaction's been really positive. One researcher called the work quite spectacular.
High praise.
Yeah, and they put out this is really the first time we've seen genuinely new scientific findings come out of these general-purpose LLMs.
As opposed to specialized AI.
Exactly. Unlike, say, AlphaFold, which was amazing for proteins, but highly specialized.
Right.
AlphaEvolve is more like a general chatbot-style AI, but it can generate these novel solutions across different fields without needing massive retraining for each one.
That seems like the key difference, doesn't it? That general purpose nature compared to the other big alpha systems from DeepMind, like AlphaFold, AlphaZero.
Yeah, definitely. AlphaFold was a biology specialist. AlphaZero mastered games like chess and Go brilliantly, but, within the fixed rules of those games.
Contained environments.
Right. AlphaEvolve isn't tied down like that. It uses the broad knowledge in the LLMs to tackle lots of different problems, as long as you can define the problem clearly and have a way to check the answers.
And it even beat Alpha Tensor, the matrix specialist.
In that specific 4x4 case, yeah, which really highlights its versatility.
So not a master of one trade, but maybe a really, really fast learner across many trades. What could that mean for the future of invention and discovery?
Well, thinking bigger picture, this could be a really fundamental shift. We're moving beyond AI just analyzing data or automating tasks we already know how to do.
Towards AI as a partner in creation.
Exactly, an AI that actively participates in R&D, generating new ideas, testing them, refining them, constantly looping. It could massively speed up progress everywhere.
Material science, drug discovery, climate tech.
All of it. Anywhere you have complex problems that can be broken down. It could empower smaller teams, too, make research more accessible. It points towards this future of human-AI collaboration, where the AI is a genuine research partner.
Like having a tireless co-researcher that can think outside the human box. But it can't be perfect, right? What are the limits? It can't solve everything.
No, definitely not. That's important. It works best when the problem is well-defined. You need clear rules, clear goals, and a reliable automatic way to judge if a solution is good or not.
So fuzzy problems are still hard.
Very hard. You can't just tell it solve climate change. You need to break that down into specific, measurable subproblems. Also, the computing power needed can be pretty huge. Running all those tests and simulations costs resources. And, like any evolutionary process, there's always a small risk. It gets stuck on a good solution that isn't necessarily the best possible one.
A local optimum, yeah.
Though using the LLMs for diverse ideas helps reduce that risk, it's still a factor.
So clear problems, measurable success, needs compute power. Got it.
What's DeepMind planning next? How do they get this out there?
They've laid out a few steps. They'll keep improving AlphaEvolve as the underlying LLMs get better. That's ongoing.
Makes sense.
They're also building a user interface, trying to make it easier for scientists and engineers who aren't AI gurus to actually use it.
Lowering the barrier to entry.
That's exactly. And significantly, they're starting an early access program for academics.
Oh, interesting. Get it into researchers' hands.
Yeah, gather feedback, see what happens when it tackles a wider range of real scientific challenges. And down the road, they're looking at broader availability, but, being careful about safety and making sure it's reliable. A cautious, collaborative rollout. Seems smart. Okay, so let's try and wrap this up. If people take away just a few key things about AlphaEvolve, what should they be?
Okay, key takeaways. First, AlphaEvolve cleverly combines the creativity of LLMs with strict, automated self-testing in this continuous improvement loop.
Generate, test, evolve.
Right. Second, it's already got real runs on the board. Big savings in Google's data centers, better AI chip designs, faster AI training for models like Gemini, huge speed-ups in core AI software like flash attention.
And that record-breaking matrix calculation.
And the 56-year matrix record, yeah. Third, it's showing promise for actual scientific discovery, making progress on unsolved math problems like that kissing number thing.
Genuine new knowledge.
Potentially, yeah. Fourth, experts see this as a new kind of general-purpose AI for discovery, different from specialized systems like AlphaFold.
More adaptable.
More adaptable. And finally, DeepMind is developing it further, working on usability, collaborating with academics, and planning for wider access responsibly.
So it's an AI that doesn't just analyze or automate. It actually innovates, finds solutions humans missed for decades across all sorts of different areas.
That's the core idea. The vision is AI like this becoming woven into how we do science and engineering, a powerful collaborator for researchers.
Accelerating progress across the board.
Potentially, yeah, speeding up breakthroughs in ways we maybe can't even quite predict yet.
It's fascinating stuff. And just to leave you with something to chew on, thinking about AlphaEvolve's knack for finding these hidden solutions, what problem in your world, your area of interest, seems impossible right now, but maybe, just maybe, an AI like this could one day help crack. Something to think about.
Definitely something to think about.
That's our deep dive for today. Thanks for tuning in.